Good afternoon, Jan.
Michael, good morning.
How have you been?
Good, good. Struggling with code. Struggling with code. Wait, let me look for the Zoom.
Yes, yes, the Zoom is started.
So, first thing we had to do, we had tools, and we had normal tools, so the tools lookup.
Mm-hmm.
And apart from that, we also had on-the-fly tools.
Right, yes.
And the on-the-fly tools, that were the tools that we added when we were working on a task, but which were not yet in the database.
Right.
Um, the idea was to get rid of these on-the-fly tools
Mm-hmm.
and to put them in the same, to present them as a normal tools fact, but to just add an approved flag.
Right,
So
yes.
tools that we import from um, the CRM system,
Mm-hmm.
these will be automatically approved. And the other ones, the ones that technicians or workers in this case add themselves, they will have to be approved by the dispatcher normally.
Okay, yeah. Yes,
Yeah.
I remember that.
So, and that's where where I was. So we are gonna do that now.
Excellent.
So the DWS that should be here in dispatcher. When I still had often another. Why is? Oh no, okay. I had an error message coming up often that said your file does not belong to the workspace, but apparently it's disappeared now.
Hmm.
And never mind. We will see when it comes back. So provisioning worker, dispatching clients, yards, tools. Here we have the tools. If we look back to here in the diagram, so on that tool fact, we
Mm-hmm.
have to add um, another flag, I think.
Yeah, so yeah, would this be um so it came from the CRM and therefore this flag is always set. Um Yeah, is this going to
Um,
be a flag that you want to change when the tool is approved?
yeah. So
Okay.
if as long as a tool is not approved, the flag will not be there. Yeah, but
Mm-hmm.
once it is approved, there is no way back.
Okay. Yeah.
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 So if a tool comes from the CRM system, then it will be automatically approved. And otherwise, when a worker creates a tool,
Mm-hmm.
it will be approved by the dispatcher. For example, to avoid that he creates a tool which is already in the database under another name.
Mm, right. Okay. Yeah, that makes sense.
Yeah. And once it is approved, it will be visible for all the colleagues as well.
Yes.
But so approved, then we only need
Yep.
is that correct this way?
Yeah, yeah. So that says exactly what you said before. That once it's approved, that's it.
Yeah.
So yeah, that's a fact that yeah, it exists or it doesn't, and once it exists, it always exists.
Mm-hmm. Type of tool. Yeah. And then the other one. Let's right. Let me save this one first. So if we say, how was it to run up to now? There was a possibility to run.
Oh, was there? I don't know about that. Yeah, I would have been
No,
using that all the time.
I I think there was something
Huh.
like that. Yeah. Right click. No.
Hmm.
Run.
Yeah, there's
Oh,
run
I must
all.
have seen it.
Yeah.
Yeah, but run all will
Yeah.
also run the. Yeah, never mind. We do
Yeah.
run all. In my mind, there was something run up to here.
Yeah. I hope there is somewhere, because that's a useful feature. But yeah, okay. So we've got the tool
Approved.
approved. Yep.
Okay, and then the task type of leaf task here. We look back to the diagram. So there, the on the fly tool.
Yeah.
We need the tool lookup. We need to. These are the relationships. Okay, here. This one. Remove that one.
Mm-hmm. Yep. Don't need those.
It's that, and then so here it is. Tool name. This one's
Yep.
task tool on the fly and on the fly delete. Yeah, like that.
Mm-hmm.
And then in the relationships.
Mm-hmm. Yep. Yeah, we don't have those. We don't have that relationship anymore.
The rest should be okay. Let's save that. Run all. So now we have
Mm-hmm.
just under task. Yeah, so everything is there. And where is my tool approved? Ah, yeah.
Yeah, that is not causally related to the worker. So
Type
yeah, it
of
doesn't pull it in.
tool.
There we go.
Did we have something already that he gives the full diagram in render?
No, you do have to list out
Yeah.
the leaf types. Yeah. Um, yeah. The idea of full diagram. You know, if there was a way to do it, I would still be kind of reluctant to do it.
Mm.
So yeah, you might be able to enumerate an entire assembly or an entire app domain and find all of the fact types, but um, but yeah, still reluctant to do that because you need to be able to focus on different subgraphs. But
Still not there. It's still not
let's
there.
see.
Did I do something wrong?
Let's see. Well, Tool approved. Oh, it's a
Yeah.
lowercase t. Why didn't it? It's weird that it didn't give you an error.
Hmm.
Yeah, so you hit restart, and you still need to hit run all.
I
Yeah.
didn't do that.
Okay. So, yep, there's
Oh, yeah.
tool approved. Yeah.
There it is. And so the other one is gone.
Yep.
Task. Okay. That's one thing.
Mm-hmm. Yeah.
Then,
Yeah. So now when you import, you're going to import both DWS tool and DWS tool approved. And then when somebody creates one on the fly, they're just going to create DWS tool.
yeah.
Yeah, and then the dispatcher can have a specification that's looking for DWS tool where not exists, DWS tool approved, and oh, that's the list of things to approve.
Yeah. Approve or not approve. Because
Yeah.
if it exists already,
Mm-hmm.
because in that case he has to delete it.
Mm-hmm.
He has to change the relationship that.
Yeah.
So the worker is gonna make a relationship between task and tool by
Yeah.
this task tool lookup.
Yeah.
And so if, for example, that worker defines a new tool, which he shouldn't because it existed already,
Mm-hmm.
he just gave another name. In that case, the dispatcher can say, I make a tool lookup delete.
Uh-huh.
I delete the tool.
Yeah. Which isn't on this graph, but yeah, it's
Yeah,
it is defined.
it is defined.
Mm-hmm.
I delete the tool instead of approving it, and he creates a new tool lookup,
Yes.
which points to the original tool.
Yep. Yep. And all of that can be automated with a single button that does all those things.
Yeah.
So it's like, yeah, okay, approve this one, and it disappears from the list, and then that one, let me look it up. It's the same as this one, so select the one that it's the same as, push another button, and it does all those things you just said.
Mm-hmm.
Yeah.
Okay. So that should, and so only approved tools will be visible to other technicians.
Yes. Yeah. So yeah, this brings up an interesting question. This came up on the Namus project when we were talking about. So this was missing persons cases, and so there was information that an officer can add to a case, and we wanted to make sure that that was approved for everybody to see before it went out to everybody. But still, the officer should be able to see the things that they themselves added. So, as a worker, if you were to add a tool on the fly and then go to another task, would you be able to look up the tool that you had already added yourself, even before it's approved?
That seems logical to me.
Yeah. So in order to support that, we would need some sort of relationship between the tool and the worker. So they could say, okay, these are my tools.
Yeah.
Which I guess we could get indirectly through all of the workers' tasks. That's one way to go about it.
Yeah. Right. If you see the full diagram.
Which actually might not be bad. So I'm thinking if I was assigned to a task that somebody else had added a tool on, I should still be able to see that tool. Maybe I want to see that tool in the list so I can keep using it. Yeah, that's an interesting question. I think we can I think we can
Wait,
resolve that
say
question
say
later.
that again.
Yeah.
If I was assigned to a task,
Yeah. So yeah, as a
yeah,
there we go. Um, yeah. So as a yeah as worker A, the first
yeah,
worker, I add a tool on the fly on this task, and
yeah,
then something happens and that task is reassigned to a different worker. So first of all, is
yeah.
that something that that is something that we support?
I'm looking here. Normally we should.
Yeah, DWS task worker. That's how we can reassign it to a different worker.
Yeah, there is the worker. Here
Yeah,
is the DWS. Yeah,
yeah.
indeed.
So now that second worker, having been assigned to the one that the first worker had already started and added a tool to, um, that second worker needs to take over and then move on to another task. So when they look up the set of tools that they can use, can they see the one that was assigned to that first task, or that was used on that first task? I don't know. I don't know if any of that made sense.
What? Yeah.
But that would be a
Um,
consequence of using the task worker fact in order to find all of the tools that are not yet approved.
yeah, because in this particular case, you go to a client as a worker. You go to a client. And there is one task to do
Mm-hmm.
in general.
Okay.
Now you might have a case where the dispatcher splits it up in 2 or 3 tasks, and in that case, yeah, it would be logic that you could reuse that tool.
Mm-hmm. Okay. So so yeah, then if that's the if that
Mm.
wouldn't be a surprise, if that would be expected behavior in that edge case, and we are talking about an edge case, um, then I think this model is exactly right. We don't need to keep track of which worker created a tool.
But if it is a different task,
Mm-hmm.
then how are you gonna find? Because
Yeah.
now we have the tool
Mm-hmm.
by the task tool lookup.
Mm-hmm.
So if it's a different task,
Yeah. So what I'm expecting is that for that even for that different task, what you would do is you would go back to the worker themselves, um, and then from that worker you would see all of the tasks that they are currently assigned to, um, and then you would see all of the task tool lookups for those tasks, and then all of the tools. So
okay,
so yeah, if they're currently assigned to a task that is not finished, not deleted, then they can see the tools that were used on all those other tasks as well.
yeah. So even tasks, all the tasks that have not been not finished.
Yeah, maybe not finished
Hmm.
is too strict
Yeah,
because you
no,
finished
because
this task, but you still have that tool.
yeah,
Yeah,
you could say the task from the same day, for example.
yeah, there we go.
But
Yeah.
can we?
If we have days in the model,
Yeah,
uh,
that,
then
that
yeah, we
was.
can do that.
Wait, how did we have that? No,
Yeah, we don't have that yet.
no.
That's okay. We can start with this and evolve our way into that once we say, okay, we want to check that edge case. Um, that would be a really exciting exercise of the versioning capabilities of
Mm.
Janaga, that you can add a
Oh,
predecessor.
mm.
So this task
No,
on this day.
what we can do, instead of using a day, because it could be that
Mm.
yesterday the technician went to that client,
Uh-huh.
finished task number 1. Today he comes back, he finishes task number 2. So he has to use the tool from yesterday.
Mm. I see, yeah.
So instead of selecting by day, we could just select on
Oh,
client.
okay. Yeah, so now you're looking through
So
all the history of tasks that,
yeah,
yeah.
um, now it seems logical what you do at a certain client
Mm-hmm.
needs a certain tool. So
Right.
even if that was long ago,
Right.
and
Yeah.
normally tools from long ago should either be deleted, either be approved.
Yeah. Okay.
So
Okay. Yeah.
it's gonna be limited.
I like that. That's
All
good
right.
reasoning. I love it.
Mm-hmm. Then so this was the end of the model,
Mm-hmm.
but then we had the scenarios here. And does the tool delete it comes up somewhere? If it comes up, we should have wiggles, I think. Eh?
Hmm.
No, it was very limited, and
Right.
I don't.
Yeah, I don't think we
No,
got to that point yet.
no. Okay. All right. So the model was adapted. I didn't. I think there was nothing else which we. That was the only thing we had to adapt in the model, if I understand well.
Yeah, I think so.
Okay.
Yeah, I think that is the only change we wanted to make.
Mm-hmm. Good. So this one. So I have. Why is there a change in this one?
Yeah, I have noticed that Polyglot Notebooks is very very sensitive.
Yeah.
Even just opening it back up, it says, "Oh, this is different." So yeah, it changes a bunch of
Yeah.
stuff. Yeah, yeah. There's all the outputs that it didn't have captured before. Um, so
With create tasks, I didn't change
yeah,
any.
so yeah, I
Uh,
think you're safe.
so don't need that.
Yeah.
Don't save. The dispatcher. Yes.
Mm-hmm.
So here, create tasks. We're gonna discard the changes. So these were the 3. Yeah.
Mm-hmm.
Okay. What did I?
Oh yeah. Yeah. Get wants you to stage and then
Yeah.
commit, and so
Oh,
this is
yeah.
asking if it
Yes.
wants to stage. Yeah.
But where did I commit here? So um, change on the fly tool. Replace tool on fly by tool approved. Is that okay?
Mm-hmm. That makes sense. Excellent. Oh no.
Why? Why?
Hmm. It must have yeah, maybe your credentials timed out.
Yeah.
Yeah, that's
Okay. This is on that virtual machine. Yeah, that's possible. Okay, I will look. I will
yeah.
look into it and and upload it
Yeah.
afterwards. Okay.
Well,
Um.
cool. Yeah, I
Yeah.
love how that worked. So so yeah, reasoning through the consequences of making model changes, um,
Mm,
and yeah, seeing the diagrams and exploring those things on the fly. So yeah, that's a process that yeah, I really want more people to be able to go through like that.
mm, good. That was a very small thing, but at least that is done.
Yes.
And then, yeah, for the next time, I will go back to Visual Studio,
Mm-hmm.
find find the code, install all the updates.
mm-hmm.
Because Visual Studio is not on that virtual machine; it's on my host machine. Um, but then,
Very nice. Yep. Yep. That's the chore. I'm going through that chore every week when I turn this machine back on and say, okay, I need to. Like I just updated Visual Studio this morning. It's like, oh yeah, I've already done that on my other machines, but now this one. Um,
I
yeah.
try to limit it. Just one main machine, and then yeah,
uh-huh.
virtual machines for special things. But because otherwise there is no end to it. Uh, yeah, and then the laptop. That's another one.
Mm-hmm. Yeah. Excellent. Yeah. So
Nice.
I've done a little bit of playing around
Mm,
with Docker Compose and Elasticsearch, continuing that thing that we talked about
mm.
last week. So, um, so yeah, some fun stuff to explore. This is very much work in progress. So, um, so are you still seeing Zoom? You still have
Yeah, I'm
okay.
seeing code there.
Yeah,
Right,
excellent.
and then this one's streaming.
Okay. All right. So that should be yeah. There we go. Had to pick the right scene so that we're back in the picture. All right. Um, so, yeah, what I have added was this file watcher. So now we can
Hmm.
drop files into the folder and see the import working. That gives us some ability to play around with things. You know, have small files, have big files, do replay, all that fun stuff. So I want to yeah, zoom in this in a little bit. Okay, so we'll first do a docker compose down -v that will delete the volumes and the yeah and the containers and everything. So we've got a nice clean slate. So let's just double check here. Yeah, we don't have the university mesh anymore. So then docker compose build. So let's rebuild the indexer and the importer with that new code. And hopefully it's got the earlier layers cached. So yeah, when you're managing Docker files, it's helpful to think about the order in which you do things. It looks like because there's been a new SDK that dropped in the meantime. It's uh, installing that SDK. But what I'm talking about is like right here, this Docker file. So So inside a build, it first copies just the CS proj files and then runs .NET restore, which you would think, well, and then here it copies all of the files, so all of the source. So you'd think, well, why not just copy all of the source? And the reason is that the source changes pretty frequently. So if you moved this above this, then that means as soon as you change the source file, it would have to redo the .NET restore. So yeah, if there aren't any new NuGet packages, then it could cache this layer and say, oh, I've already got those packages restored. So yeah, I think what actually changed is this base image. 9.0 is a tag that actually moves. It's not so specific that it's locked down to a certain version of the SDK. So the latest version of 9.0 is what that tag means. So it probably, oh, there's a new tag. So let me pull that.
9.02, I think.
Yeah, something like that. Does it say? I don't think it says in here. Yeah, because that would be another tag on that same image, and it doesn't know what the other tags are. Yeah, but yeah, having it in this order, that means that as long as everything else is the same, then when I change a source file, it just starts from here. Everything else before that is cached, and then it just does the build and publish. So, yeah, 47 seconds, not bad. Okay, so we've built the importer and the indexer. So now docker compose up, and that creates the university mesh and gets everything started up. And we can see Elasticsearch running. We can see indexer running. They're all kind of woven together. And there's the replicator started up. And so this time we didn't see things just flow into the replicator. We didn't see it importing a whole bunch of stuff. And that's because
there's no CSV file.
Yeah, the CSV file is right there. So here's our university data. We've got some GUIDs that represent the offering. In fact, let me see if I can just open this up in Excel. Make it a little bit easier for us to read. There we go. So, insert table, nicely formatted. Okay, so we've got these offering GUIDs. So we can keep track of which one's which. And then we've got the course code and the course name. And these three things taken together identify the offering. So we needed the GUID in order to be able to run the same course. And the same and the semester. So here's the year and the term. So yeah, if these four are the same and we didn't have the GUID, then we could only run this course once in the summer. And that's not what we want. We want multiple offerings. So then along with it, we've got the instructor, the building, room, days, time. So just a whole bunch of flattened data, and we want to import it. So what I can do here is take this data file, and inside of the mesh, I've got there it is, the data folder that is mounted to the importer. So I've got the import data path here. And so there's the import data path. Drop your files here. There's also a processed path and an error path. So we can take the data, drop it into import, bloop, and then it does its thing, and then it moves it to, it should move it to processed.
Where does that label drop files here, where does that come from?
Oh, that's just an empty file that I that are
Okay.
checked into the repository. Yeah. 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 I wanted,
Just
yeah, first of all,
the name
instructions.
of yeah.
Yeah. Yeah. Just an empty file.
Mhm.
But yeah, that also tells Git to keep this this folder around. So imported all these courses, and we can see the backend replicator getting into the action. So we imported a few courses. The replicator says, "Oh, we've saved 45 facts during the past second." So it's just outputting this line once a second to tell you the total number that were saved during that second. And then something else loaded 5 of those facts. What was that something else? Well, here we've got the indexer. So it's moving that data over to the indexer. And so it says, okay, I've finished indexing the machine learning course. Okay, we saved another 42 facts. So we loaded 5. So we see the importer doing a lot of work, and the indexer just every once in a while picking out one of those courses. The reason for that is that these courses are for all sorts of semesters. Yet the indexer, if I take a look at the indexer code, we can see, here's our seed data. Okay. New data seeder. That it is only, oh, that's the university and the creator. We are looking at the CSV file watcher. This guy here. We are. Oh, okay. Yeah, the importer is importing everything. It's the indexer that we want to take a look at. So here's the indexer program. Okay. So we want to take a look at spring 2022. So that's our current semester, and that's where our offerings to index starts. So that means that we are only interested in spring, not 2023, but spring of 2022. So we'll pick up that course. So yeah, machine learning was the first one that that was imported that matched that specification and needed to be indexed. Mm-hmm. So that's why we're importing a whole bunch of things. And so we can see, where's our 501? Here's our machine learning gets imported here, and then it's indexed over here. So yeah, makes its way through the replicator and into the indexer. And then that wakes up and indexes the record. So now at this point, you can see it is just setting all of these mutable properties to TBA. So, and I think we saw, where's our, yeah, I think we saw this last time. If we go to localhost 9200 offerings and do a search there, we see that we've got a bunch of offerings with everything set to TBA. So a total of 22 offerings. It's only showing 10 at a time. So we just see 10 records right now, but we have 22 total. So you would hope that, let's cross our fingers, if I just look at 2022 and spring, we should have 22 offerings. Yay! Yep. Excellent. That might be behind. There it is. So good. So that part is working. then the next thing that I wanted to do was to try to manage those updates. So this is where things started to go wrong. So let's stop all that, and then come on, replicator, you can stop. There we go. So then we docker compose down -v, so that deletes the volumes. So that deletes all of this this Elasticsearch ES data. So yeah, I was doing testing with this. I had forgotten the -v, and it's like, where did this data come from? I told it to just index 1. Oh yeah, actually there was one thing I wanted to show before doing that. So let me get back to this. So we've got this processed data, and yeah, since we've deleted all the volumes and everything, this is this data hasn't actually been processed by this mesh anymore. So drop that back into import, and come on. Oh, that's because I've got it open in Excel. All right, so drop that into import. You can do it. Well, let's see if I can just... Yeah, Git's not able to do that either. Okay, let's restore that. Yeah, why is it... yeah, Excel still seems to have it locked. Anyway, we will try it this way. So now I've got it back here. So hit import, boom, and we see doing all the importing. And when it's done, it should drop it back into, well, it tried to drop it back into processed, but it couldn't overwrite the existing file. So it put it into error. Hey, that's fine. Yeah, hey, that file already exists. Boom. Now, let's suppose that I were to see this again. So I've already done all of this work of importing and indexing. Let's go ahead and grab this, drop it back into import. Let's see. Wow, I can't go from error to import either. Oh, that's very unusual. Okay. Well, let's just stop the things. We're not going to take them down. Let's see if it's the containers that somehow have things locked. Okay, stop. Okay. Well, let's just try a reload window on this, see if that's the thing that's got them locked. I have no idea. So, no. Yeah, so those are stopped. Excel isn't running anymore. Let me just... Yeah, check Task Manager. Excel's now running. Yeah, I have no idea what could possibly have these files locked. But here we are in here.
If you just make a copy of it,
yeah,
you cannot move them, but you can make a copy probably.
Yeah. Cannot find this item. It's no longer there. Well, I can see it. Oh. All right. Data. Oh, the folders are gone now. Interesting. Okay. Here we are. Let's do a reset hard. And Git still doesn't have permissions to unlink these folders, but that's because I can't see those folders over here. Huh. Okay. Reload everything. Okay, well, let's do a rename here. University Data 2. Okay. So now we've already imported, we've stopped the containers. Let's do a docker compose. Wait, no, we don't want to do docker compose up because the containers already exist. I just want to go to the desktop here and start that university mesh. So everything is started up again. And I see the importer here. So here's our new logs. So ready to import courses. Let me clear those out so that we don't get confused. And then we've also got the indexer, and we see those are the previous logs. And here it's starting up again. So let's clear those out so that we don't get confused there. And so now I've got University Data 2. Let's import it. Boom. And let's see what happens here. So the importer is going through all of the rows in that file and doing its import thing. So when we take a look at the code, we'll see that it writes this out no matter whether this is a new fact or an existing fact. It's just always writing it out. But on the importer side...
Yeah, Shinaga stops it because it's the same fact.
Yeah. On the indexer side, right here, no new logs. So nothing new was indexed because it stopped at the replicator. It didn't. It said, oh, I already know about these things. I don't need to tell anybody about them. So yeah, so we've got that that anti-duplication just kind of built in. If you don't introduce anything that's that's non-deterministic. So taking a look at that on the importer, we've got our CSV watcher here. Boom. And so we're watching for these files, and then when we get a file, we're going to call get records from the CSV, and then for each record, create those facts. So we've got that whole async for each thing, because this is an async enumerable. So that's fun to play around with. So when we create the facts, we are setting up a few specifications here. So we can talk about those specifications in just a little bit, but right here where we create the course, we are just using information that is consistent. So from the record, we're getting the course code and the course name, and we're using that university that we've set up when we initialized. Semester is based only on information in the record, the year and the term. The instructor is based only on information in the record, and then the offering is just that course, semester, and this GUID from the record. So we're not doing GUID, new GUID here. We're not using date time here. So all of this is consistent stuff. It's deterministic. Yep. So that means that we will get back the same offering if it's already there. And then we start to run these different specifications. So we are looking for the offering locations, and we're looking for the offering times. This little extra bit here bugs me. I need to figure out how to change the type signatures so that doesn't happen. But it's an identity select at the end in order to get it to the right type. But yeah, that will go away. We should be able to just match against a relation.
Yeah.
And then with this one is interesting because I'm starting with the successors of type offering instructor, but then so that gives me the offering instructors. What I'm really interested in is the the instructor facts. So this fact right here, to the instructor, not the offering instructor. And so so when we process the location and the time, we're doing things a little bit differently than we are for instructors. So now we've got that data from the record, and then we run this this query, and we see what offerings do I already have saved, or locations. What locations for that offering do I already have saved? And if I have exactly one, and that one is for the same building and room, then there's nothing new to do. But if I have 0, or if I have more than one, then I need to create that offering location and bring those back together. This is also some extra stuff at the end that it kind of upsets me. I don't want to have to do that, but I understand why I do. I might not be able to get rid of that, but I'll try. And then, actually I might be able to get rid of this part because I didn't use it here. Anyway, so I've got, so if there was none, that means I haven't restored that location before. If there was more than one, then there's been a concurrent edit, and I need to resolve that. If there was exactly one, but it was for a different building or a different room, then there's been a change, and I need to record that. So that's the general pattern for importing the mutable properties. What changes here with instructors is I'm not talking about specific specific string values inside of the record, but instead I need to compare it against this instructor fact here, which was then based on the string that's in the record. So if we get back the same instructor as is already connected to this this offering, then there's nothing to do. Now I can't just compare this object, this C# record, with this C# record, because even if they represent the same fact internally, they will, in this case, they always will represent, they will be represented by 2 different C# records. And that was a thing that I tried to do in the library toward the beginning, and I realized that it was basically a memory leak. In order to keep track of all of the records that you had created, and then compare them with the new record that you're getting, that you're pulling in, to make sure that it gives you back the same instance. So then trying to turn those into weak references so that the garbage collector could clean them up if you're not using them. It was just a whole lot of complexity. So I was like, things are just a lot simpler if you just compare the hash codes. So that's what I recommend in this scenario. And it comes up so infrequently that it doesn't make sense to add a whole bunch of overhead to the library for this this one pattern. But so that will cause the importer to reuse existing facts if they're already there, and then it always does the console write line. It has no idea whether this j.fact had any effect. It's just, okay, I want to ensure that this fact exists. So yeah, that is what's going on so far with this thing. Yeah, now we can't see it in there. We can only see it here. So yeah, importer doing all the import stuff. The backend replicator processing facts. So right now it's only working at about 300 facts per second. And that's because I haven't done any optimization at all. There are definitely some things I can do to get that number where it needs to be.
300 per minute is already not that bad.
Mm-hmm. Yeah, for a medium-sized application, not terrible, but yeah, if you compare that to what you can get out of Kafka, that's laughable. Kafka is like it's way faster, but we will get there. One of the things that will improve the performance is, let's go all the way back to the program, right here where I client factory create client factory. Okay, there it is. Yep. Yeah. So I do Janaga client.create, and I'm setting up the endpoint. So I'm pointing to the replicator URL, but I am not at this point setting the. Oh, I can't find it. Why can it not find it? Okay, something wrong with my C# plugin here. But there's another property on options that tells you where the SQLite file should be stored, and if you don't set it, then it uses the in-memory store. So we'll set SQLite path, and then I think that's the name of the property. My little friend over here with the goggles just guessed, but yeah, and that is the name that I tend to use for it. So it's getting that from somewhere, but that shouldn't be in context. Weird. So yeah, as soon as I set that, then it will persist things locally, which ironically should speed things up. One of the problems is that come back to CSV Watcher. When I await j.fact, I don't resolve that until I know that it's persisted somewhere. Which means if you're using an in-memory store for this process, I await the HTTP call. It's like, I'm not going to resolve until it's on the replicator. So that means this is making a call to the replicator for each one of these await j.facts, which is clearly not not the ideal way to go about it. Instead, once you've got a persistent store, await j.fact will resolve as soon as it's persisted to that store. So a lot faster to just put it in SQLite. And then there's a background thread that it just starts up to send it to the replicator. And so it will start sending the first one. I don't think I have it pausing to wait for more. I might. I don't know. I'll have to see what the behavior ends up being. But yeah, in the worst case, it's just going to go ahead and start sending on the first one. Meanwhile, it's going to create a whole bunch of facts in that persistent store, and then when it gets finished, it comes back and says, "Okay, let me check my queue now. Oh, a whole bunch more," and starts to send them in batches, as as many as it has. So you get that that kind of back. What do they call that? Back pressure. So then that will, ironically, by doing a little bit more on the the client that will increase these numbers. Because you won't be doing them
Why?
one at a time.
Why ironically?
Because yeah, I find that ironic because you're imposing more work on, or it seems like you're imposing more work. Right now it's like, yeah, you don't have any work to do. You're all in memory. Everything should be nice and fast. Yeah, here, oh, you've got a little bit more work to do. You have to store it locally first. But yeah, that doing a little bit more here has a global performance improvement. So yeah, it's just, are you thinking locally or are you thinking globally? So yeah, I'm putting things in place right now in order to see that happen. So what I want to set up next is Jaeger. I want to see open telemetry. I want to see the information flow. And yeah, we talked about Prometheus. I'm starting with Jaeger actually. Jaeger and Prometheus are two open source open telemetry visualizers, and based on really quick research, it seems like Jaeger is going to give me the information that I need right now. So I'll start there, and then I'll also add Prometheus, and that way we can, both of them will be there in the example. You can just compare, and yeah, we'll make sure that Janaga works with OpenTelemetry, and we can see all the information we need. That'll be a great demonstration of, I make this one line change, and then the throughput goes through the roof.
You said that you had troubles with updates.
Oh yes, yeah.
But you mean if you change something, for example, the name of a course or the time, and then you in the CSV file, and you import it again?
Yeah. So right now the code that we were just looking at doesn't create any of the update facts. So well, I'm sorry.
Adds new.
No, yeah, I'm sorry. The code that we looked at does create the mutable property facts. It's on the indexer side. That code, which we didn't actually go through, but that code just indexes. Oh yeah, we did see it. It's all the TBDs, TBAs. So yeah, I've got another branch that that looks for changes to those mutable properties and then updates Elasticsearch. So yeah, didn't get a chance to show the errors that one's running into, but there are two problems. One is that Elasticsearch is not it is not liking the fact that I'm sending it 3 updates at a time. So it's like I'm looking for changes to the time, changes to the location, changes to the instructor. And so I get all 3 of those mutable properties at the same time, and all 3 of those specifications wake up and say, all right, update that that record. And Elasticsearch is like, okay, I'll take the first one, but these other 2, wait. And Elasticsearch isn't set up to just let me wait for you and then I'll do it. It's like, no, Elasticsearch is supposed to be just really fast. It's like, nope, the index isn't ready yet. Boom, you're failed. So it kind of pushes that work back to you to kind of batch up your work and say, okay, here's all the changes. Let me send it to you. So that's one problem. And so I think I'll show the problem and then I'll show the solution because it does change the way that you write your indexer. But then the other problem is a Janaga problem where I am getting into Postgres, and even though if you just reason through, so I'm basically getting a uniqueness constraint violation in Postgres, and so it's trying to insert a fact that already exists. But I've already got checks in the SQL. So, if this fact, select these facts where they don't exist, and then do the inserts. And so just thinking about it, if you reason through it as if Postgres was serialized and you're just doing one thing at a time, then it should not be possible. And I'm doing this inside of a transaction, and transactions give the illusion of being serialized, but so it should not be possible. And yet, it's happening. And that's because, if transactions truly did serialize, performance would be terrible. So, they're doing all sorts of tricks under the covers. And so I'm running into one of those tricks. And so I just need to work my way through it and resolve that. So then you'll be able to send facts as quickly as you can to Replicator, and it will do the right thing. But
the Replicator takes care of it.
Yep. But as it is right now, I'm just flooding the Replicator with all of these concurrent facts, and I say, oh, wait. And so ironically, there you go, using that word again. If I were to turn on SQLite in the client, then I suspect that Replicator problem would go away, because turning that local storage on will batch up the facts and basically give the Replicator time to recover. Even though it's now it's really just talking to two processes versus several different I'll say threads within those processes. It's not really threads. It's task completions, whatever you call them. But so changing multiple connections into single connections will resolve the problem. But I don't want to do that until I've fixed the problem, because I know if I actually flood it with a whole bunch of processes, it's still going to do the same thing.
Yeah, that are the hidden problems.
Yep. And that's what I'm really loving about this demo, is I can expose those problems. Okay, once you actually use a Replicator the way that I know it should be able to be used, hey, you run into this. I did not know that would happen. That's the risk of being a software mathematician. You prove the correctness of your software, and then it breaks. What?
They say there must be another theory.
Yeah. Yeah, because my proof is based on this assumption that I make about transactions, and it turns out that assumption is not true.
You will find out why.
Yep.
And a solution.
Yes, indeed. Yeah.
Good.
And then I will give you a new layer of abstraction that I've done all the hard work to make sure that layer of abstraction is as close to true as I can make it. And now
I'm
you
confident.
can prove things based on that. Yes.
Good. So next week and the week after, I think it's 2 weeks that I will not be there. So the 20th and the 27th I will not be there. I'm back the 3rd, so the 6th of March I will be back in the
Very good.
seeing your demonstrations.
All right. Excellent. So I will I will put together some demos. I might do them live, or I might pre-record them. I'm not sure. Whichever one works out. But I do kind of like doing them live because things break, and hey, I can't edit. But But I also do want to put out some YouTube shorts. These videos are over an hour long, and I want people to just be able to say, hey, look, boom, here's a replicator. It did a thing. Done.
Yeah, which is just focused on a certain aspect.
Yeah. Yeah. So maybe do some demos. Pre-record them. Have them at 20 minutes, and then extract from there a short, at most 2 minutes of seeing the thing do the thing. They have to be vertical. I still haven't figured that out. The whole TikTok, Instagram vertical. It's like I am not a vertical person. You see this gray hair? I am not vertical.
Yeah. Okay. I will see which ideas you come up with.
Very good. Yeah, enjoy
Anyway,
your time away.
I take my computer with me, so I might have a look at it.
Very good.
Okay, Michael. Then see you in 3 weeks' time.
Yes, I will see you then.
Okay. Bye bye.
Bye.